Hello everyone, it's Jeff Wagner here. I'm glad to have you all with us. And for the next hour or two, we're going to be taking a look at all the various different ways in which you can configure and use Houdini. It's targeted for those users that are new to Houdini and might have experience with other applications or not. But we will be taking a look at how I like to configure Houdini, because remember, it's my way of learning Houdini. And it's a way that had quite a bit of success trying to get all your users out from just following all the tutorials and your day-to-day work, doing things rote-wise, just memorizing a few nodes and then putting those things down or using shelves. So this is an exercise to see if we can expand our understanding of Houdini. And so that's exactly why I wrote what I did. So basically, we want to use Houdini to its fullest. And to do that, we have to understand a lot of the various ways in which Houdini was architected, how certain tools work, and why they work that way. And once we start to realize how things are put together, we start to see the duplication, the repetition in a great many of the tools that we use. So the very first thing I want to take a look at is workspace setups for success. So when you start up Houdini, you end up, very first, when you start up Houdini, we end up with what this is called the build desktop. It's a desktop that's used to do the majority of our recordings, and I find that a lot of the users out there will instinctively use this build desktop because it's the default standard. I really do enjoy using a different desktop. It's called Technical, but in my own default setups, I actually call this work. It's where I want to do all of my work. So the Technical desktop, which I'll click on now, and then I'll go take a look at the desktop again so we can hover over this a bit. What the Technical desktop offers us is a bit of a deeper look at the various work scenes that we're working with, and it gives us a few extra UI panes already created for us that we can use as we traverse our scenes. I find that with the Technical desktop, I can load up almost any scene that I want. In this case, let's open up one of the scenes that we're going to be taking a look at today, which is the trail operator. It's one of those key operators. And the Technical desktop right away gives me a tremendous amount of information, more than what I normally see. And we'll step back a bit and take a look at what is Houdini. Houdini is really a folder system. And now with the Technical desktop open, we have this thing called the tree view. Yes, you can add a tree view to the build desktop. And by the time you end up customizing the build desktop, you might very well end up with the Technical desktop. Stow bars within the interface. Each one of these panes, we call these panes, can be pushed around, reconfigured, flipped around. We've got these stow bars and hover bars here. We can expand full or contract, or we can drag these down. What I like to do below the viewport is I will generally, there's two stow bars available to us. We have the first one is where we have a Python shell, a text port, and the render scheduler. But I'm going to stow that for now, if I can stow it. Let me just go back. It's not on full screen. So I can actually stow that or unstow that. So the text port is something that we will be looking at later today, because it is a very useful tool in understanding all of the different scripts that we can write inside of operators. And then the more importantly is the geometry spreadsheet. So as we take a look at this particular operator, we can see very quickly where we are within the tree. So we're in root is slash. We have a bit of a Unix underpinning. And then we have object. Fiona's laughing because we are very workspacey. So obj is a directory folder that contains all of the objects that we're currently working on. And you can see a lot of these acronyms that we use, such as shop and vex, start to be used within the tree view as well. So under obj, we have my grid object 1. And inside of this grid object 1, we have a whole bunch of operators. And many times I'll just use the tree view just to pick a node, just to jump to that network. And one thing that we like to do quite a lot is, and I'll just play forward anyway so you can see what this particular scene is doing. It's essentially just taking a source grid and building some nice trails off it. This is one of these iconic workflows inside of Houdini that is used all the time. We're going to take a look at how to set this up next, because it's a really great example of what you can do to generate some interesting data. So stepping back a bit again, we have the geometry spreadsheet. We also have this thing called the performance monitor. I'm not really interested too much in that today, unless later on you guys want to see that. But it's the geometry spreadsheet that's really critical when we are working on operators. And the thing that you cannot avoid inside of Houdini is nodes. Nodes are everywhere. As a matter of fact, everything in Houdini has to be done with a node. There is no script that we could just run on some geometry and then generate a cached result, unless you really, really want to try it. And getting back to the underpinnings of Houdini, it really goes back to the early days with side effects, and even before that, where the idea is to animate anything, anywhere, at any time. And that's why Houdini is the way that it is. You wouldn't normally associate Houdini with animation, but it is possibly the most powerful animation tool out there, because it allows us to change anything we want, anywhere, at any time, using these nodes or these operators. In this case, I'm in this network called geometry, and I call these SOPs. So let's get on to starting off a new exercise. So discard a new. So now with ourselves in the technical desktop, I'm now going to start off by just adding a grid, and we can use the tab key in the viewport for those of you not that familiar with Houdini, or I can press the grid off the shelf tool. Either way, it builds me a grid pane, and let's call this trail grid. So a really simple exercise, but through this exercise we're going to actually explore deeper what it is that we can do inside of Houdini. So dive inside of this and we end up with the grid. And the grid is, it's got so many rows and columns and it has a size to it. For those of you who know, middle mouse on the actual name of a parameter opens up the ladder handle. So middle mouse hold allows me to choose any gradation I want to change the size of this grid. So let's make it a bit smaller. Let's say 0.2 by 0.2. I like to teach Houdini, so it's really not that key on the values themselves. And I want to take this grid, and I also want to copy it onto another piece of geometry. So in this case, I'm going to copy it onto a sphere for now, just temporarily, because we want to take a look at how Houdini orients things. The primitive sphere, and also as well some of the quirkiness inside of Houdini. Now that we have the technical desktop, we can actually see that we're working inside of a single object, inside of the OBJ directory, trail grid 1. In this particular network, we're actually building geometry. We call this SOPs. And we have generator operators, those nodes that can create geometry, and then everything else is a modifier SOP. SOP stands for surface operator, and I'll be using these acronyms for now and moving forward. So I can change this into a polygon mesh. Now, one of the iconic SOPs that is in almost every network is the copy operator. And it's one of those nodes that has yet to be removed or changed significantly. It's been enhanced significantly over the years, so it's enabled all kinds of different behavior. But in this particular case, we just want to take a grid and copy it. And now we're always marching display flags inside of these networks. Beware that simply selecting something means that it's not going to render or output if you're saving this as a cached piece of geometry. You really do need to manage your display flags, because inside of this object trail grid 1, we only have a single display. So now I can take my sphere and I can copy the grid onto the sphere. Why a sphere? Because everybody knows a sphere has these intrinsic orientation normals associated with it. And the copy operator is trying to use those. And the very first thing you need to realize is in Houdini, the copy swap basically is a stand-in for instancing. As a matter of fact, it can even do instancing as well if we were to turn this grid into an alembic archive or what we call a pack primitive. So in this particular grid, Houdini always aims things down the z-axis. So we can see here that the grid is defined on the zx plane. And let's move our display flag and select it and actually take a look at this grid. So we have our local coordinate system. Houdini is y up, and we can see that the grid is lying on the zx plane. We actually want it to lie on the xy plane and point down the z-axis. And watch what happens when I display my copy operator. And I actually go to the grid and I change it to the xy plane. Now the grids orient correctly. So that's the number one thing you've got to realize when you're dealing with instancing with these copy operators. Natively, even though you have your object, your buildings going up in Y, if you want to instance your building a million places, you might want to put a transform on that. And if you wanted to adhere to surface normals, you might want to just point your building down the z-axis temporarily with a transform placed between the grid and the copy. But now that we got that, we can use the copy swap to do a whole bunch of other things. We can actually say add 2 copies, and then we can do a bit of a translate up or translate in Z. So this is another important concept inside of Houdini, and I'm going to set the rows and columns of this grid to 2 by 2. So we now have 2 copies. So it's really important to know that almost all the operators inside of Houdini, almost all of them, will use attributes intrinsic on the geometry or attributes that we create on the geometry. And the nice thing about the copy operator is it does all of these transforms prior to copying it onto the sphere. And as a matter of fact, as soon as we put the sphere into the right input template, it'll use every point in that sphere as a program, so that as a procedure. So basically each point in turn, starting at point number 0, all the way up to the total number of points on the sphere, it will actually do that copy operation, each one in turn. So it's really important to realize that now the copy operator is working as a for loop. For every point on my sphere, do the grid and the copy operator. So that means now I can start changing the scale of my operator. And I can add and decrease the total number of copies if I so wish. So now what I want to do is I can then, after the copy, we have another notion in here, which is I'm going to put down a skin operator. And I'm going to see if I can loft or skin all the pieces pairwise. So the skin operator, when I first put it down after a copy operator, it wants to basically skin all the primitives in turn. Historically, side effects in Houdini has had operators that allow us to work on patterns. If there is a pattern in the geometry, which generally you will get in a procedural system, you can then work with those patterns. And the way the copy operator works, as I said before, each primitive in place, and if I turn on my primitive numbers, oh yes, we're recording. So you can see here that it's doing exactly what I said it was doing. So for each point, you can see there's 10, 11. And if you look hard enough, you'll find there's 0 and 1. So based on the point number of the original sphere, you can see that over here, that's where 0 and 1 is. And then you can find 2 and 3 and 4 and 5. And yes, if you're starting to see how it works, you can do that. But in this case, where we have 2 copies. So we can actually go to the skin. And you'll notice here in the very option we have the skin all primitives. And if we hover over the skin, we give you some nice tool tips. So all primitives, we want to do groups of n primitives. And look at that, defaults to 2. And if we want to create a channel reference between the two, there are many different ways to do that. But I want to drive this parameter here by the number of copies. And there's a couple ways that I know that I can do that. The first one is I can actually right mouse on the parameter itself and press copy parameter. And then on the skin, I can right mouse and say paste copied relative reference. What's a relative reference versus just a regular reference? It all has to do with the paths that referencing in the function that gets placed. So first, let's blindly do the relative reference, because I'll do relative references 9 times out of 10. And what it does is it puts in, this is our Unix underpinnings yet again. And let's take a look at the tree view and see if we can follow this along. So it's very straightforward. Dot dot slash means go up a directory. Each one of these nodes is itself a folder. And you can see here in the skin. So basically, if I go up out of skin, I'm now in this general network. And then I'm looking for a node called copy1. And there's copy1. And then finally, NCY would be the name of the parameter that we referenced in. So if I go to the copy operator and I hover over a number of copies, I can now see that the parameter name is NCY. Taking our time with this, because everything is driven with these channel expressions. And the one thing you'll notice as a newer user is you can't see that, that association between these two nodes. So let's fix that right now. In the network view, we have an I view, and we can view all the dependencies for all of our operators. So if I press the dependency tab, by the way, that was the display options for the network, and the hotkey is the D key, by the way. D is in dog. So if we go to dependency, I can now say show local dependency links. Now we can see a link between the skin and the copy. And that link is actually that, that channel reference. But in terms of Houdini, we just need to know that there is a dependency between the skin and the copy for now. I'll leave these running for now. If you wish these links to show up all the time, you have to save them to a desktop. But for now, I'm just going to close that. So now we have a skin.
I have a question.
Oh.
Not sure what the skin node does, that it usually refers to rating.
Okay. Oh, Jesus. Welcome to Houdini. Yes. So the question here, and this is an apt one, is skin. This is a really old operator. It's as old as the copy operator. It goes way, way back. It's one of these foundation operators. Skin, in Houdini, you got to realize that nodes or operators, in this case the SOP called the skin SOP, has many different behaviors. And these behaviors were added over time to solve specific problems, invariably on features or in games or commercials. Some user requested this behavior that we added to the operators, and they start getting multifaceted, and they can do all kinds of things. Skin does lofting, and yes, other applications, skinning means binding a surface of a character to some bones, so then you can animate the character. In Houdini, we have a skin operator, which simply builds us a skin across some lofted cross sections. So you can consider in this case a loft operation, but that's what skin is inside of Houdini. So it's this operator that has 2 inputs that allows us to take any number of primitives and create it. Now that I've got that channel association, I can press the N key several times to actually see what value is evaluated to the expression, or to see what the expression is itself. Values are good enough for now. But now I can go inside the copy operator, and I can now start increasing the number of copies. Many times you've seen all these really amazing generative arts sort of applications of Houdini where people create some really whacked geometry. Invariably, they're going to be artists, may or may not be technical, may or may not know any expressions whatsoever. And by just doing some crazy stuff, you can start getting some really interesting geometry. For instance, now I can start rotating any one of these parameters. And rotates in tens, please, Jeff. And you can now see you can start twisting things, and you can start bending stuff, and you can actually start twisting things as well. So you can have all kinds of fun building your various primitives as well. And playing around with the scales, you can scale it in one direction more than others. And remember, these transforms are relative to the grid coming into it. So it's Houdini. You're playing the game right when you start working with these operators, and it is an interesting game where you have to understand the logic of what these operators are doing. And working things up step by step is the best way to do things. So now we have a really basic example of a skin loft. Now another principal concept inside of Houdini, which is quite unique from anywhere else, is we can prototype anything we want on any geometry we want. And these operators are very tolerant to changing inputs and changing dependencies. For instance, the sphere operator, I can put down whatever I want. And for this, I'm going to press the Tab key. The Tab key opens up all the nodes. If you're familiar with, for instance, Nuke, it's very similar in the way that it works. In this case, I actually want to get and add some of the test geometry. Let's add the rubber toy, Flippy the rubber toy. And now I can wire Flippy into the input as well. A lot more points and a lot more geometry. One of the things that we're constantly working on right now in side effects is making these operators ever faster and more efficient, because we have to, because everything, as I said, is a node and everything remains alive. But now we actually have some test geometry, and again, every point on Flippy is now driving that copy operator. I always get the question, what happens if you deform Flippy? Well, the answer is, if you, for instance, people say, well, what about deforming? If I deform with chops, if I deform with bones, to me it doesn't matter. A deformation is a deformation. So if I'm testing stuff out, I don't have to go the whole hog and create a lattice and have a shot at one shot at doing this stuff. I just always put that a mountain operator. And mountain operator is my generic deformer. And you can see here, by changing the offset, you can mangle them up pretty well. And all this is behind the scenes, mountain is written in this vector expression language, which we call VEX. So VEX is just a vector expression language. And we have a nodal interface, which we'll take a look at a bit later. But now mountain is my fractalizer. It's a fractal type application. It's a fractal node. It applies fractal noise. And I can apply some subtle, but again, I can actually take a look at my skin while I'm doing this all the time as well. And now I can change my height. But as you can see, in some pieces of geometry, it gets really slow depending on how many copies you have. That's why you want to prototype stuff on simple geometry. So Houdini offers some really amazing things inside of here. I always use switch operators. And once you start to take a look at what they do, you will too. So that means I can actually switch between different, let's actually take a look at the test geometry. And I want to put the mountain after the switch. So we can rework networks freely as we want. And now we can test the mountain on our simple example. And then we can take a look here. And so, pardon me, let's go to the mountain, and I'm just going to change the offset. And now you can see everything updates. So it doesn't matter what this is. So generally, when I'm working on these networks, I will put them out into different areas and label them as such. So in this particular case, this mountain is actually just a generic deformer. So many times what I'll do, I'll right mouse on the output tab of a node and type in null. And when I put that right mouse on the output, and then I can call this capital out, 2 underbars, just 2 spaces, and I put deformer. So it doesn't, to me, I don't care how the geometry deforms. If I want to build a more elaborate deformer later on, I will do that. And then in here, I will right mouse and put down a null and plop that down below and just call this out source geometry. And this now, if somebody else opens up this scene file, they'll know exactly what I've been up to. They know that there's going to be a deformer up here, and you'll know that this is where the source geometry is, and there's a little switch here, so they know you can switch things around. And this is where the meat of the work is happening. So now what can we do? Some standard things inside of Houdini for creating more interesting geometry into the copy operator. We can use, so let's go over here, move this down a bit. We can actually use a scatter operator. And scatter allows us to just add random points wherever we want. So let's put the scatter down below. And move our display. I'm always marching display flags. And the display flag right now is in the skin loft. And so I'm going to move my display flag up into the scatter. Remember, Houdini has current, show me the current node in wireframe, but the display operator shows me what's being output. So now I can see here on the scatter operator, I'm simply scattering some points on the geometry. And there's all kinds of options that I can do. Now I have complete control over how many points I want to scatter. And then I skin loft that. And now you notice that I have no surface normals. So what I said earlier on, the copy operator can interpret and build its own frame of reference when it's given some nice geometry with a surface on it. But now we've created some points, and these points have no frame of reference for the copy operator to work with. So these are always one of these gotchas inside of Houdini. So let's figure out what's going on and how can we fix it. So up in the switch here, if I turn on my primitive normals, we can see that the primitive normals are nicely defined. The copy operator will actually use these primitive normals to the point normals and use that to orient our geometry. So out of the box, you get a really nice experience. Unfortunately, once we add the scatter operator, there's no more primitive normal. So we lose that nice orientation. So what do we do? The answer is classic Houdini workflows. We need to create surface normals. So let's add down a normal operator, tab normal. And in the normal operator, we can apply normals to vertices or to points. Let's add them to the points. And now we can actually take a look at the surface normals on our scatter. So the surface normals on our geometry, we can see they're nicely formed. We'll turn off the primitive normals. And that will form our hook. And I can't tell you how important capital N as an attribute is for normals. Middle mouse on the operators. I break middle mouse buttons on mice at least every 2 to 3 months because I use this so often. Middle mouse on every operator tells you what that operator has cached as a result of it processing its input. And here we can see now it's got a capital N, which is a 3-float normal. So that's what 3FN stands for, 3-float normal. And we have P as an attribute, which is 3-float position. Now, attributes. We have to step back a bit. Houdini, as we saw with the skin stop earlier, not being a skinning operation that we're familiar with other applications. When we talk about attributes in Houdini, it's specifically about geometry attributes. It doesn't mean a property of a piece of geometry. It doesn't mean wires that we need to manage as properties that or attributes that we assign onto an operator. Attributes in Houdini means geometry attributes. In this case, we have point attributes, surface normals, and P. And with this geometry spreadsheet, we can see the normals. Yes, Fiona?
I've got some questions.
Sure.
So,
I need to put my glass.
let me just read one. From Ken Finlayson, he wants to know what is the difference between relative and non-relative reference, and why would you use the non-relative?
Okay, so when we were looking earlier on at the channel reference, when would I do a non-relative channel reference? Only when the reason why I'm using relative channel references is because they play nicely with digital assets later on. I'm really setting myself up for when I compress this. If I wanted to turn this into a tool, it sets me up. When I use full paths, when I actually want to see explicitly the full path. As well, there's a couple operators inside of out that absolutely need full paths. As a matter of fact, there are some operations that absolutely require a full path to be present in order for the function to do its work. They're not that, for the average Houdini user, you'll rarely run into those conditions and cases. So for now, relative references work very well. Yep.
Okay, next question. From Jonathan Ramirez. Why is there no one-on-one default scale relationship between some primitive circles to sphere? They're twice as big as a box, and a grid, for example.
Yeah, so the question is, with the generators, we have the sphere. You're absolutely right. So spheres come in with a radius of 1 as opposed to a diameter of 1. And then we have a box, and we can put down a box, and a box comes in with an absolute size of 1. So let me just select the box. And you can see the box is a size of 1, which we can then move off. So yeah, it's for historic reasons. But what you can do is if you really want your sphere to come in at 0.5, you can reduce the radius to 0.5 as you will. And let's say you never want a primitive sphere. You always want to have, let's say, a polygon sphere. And that polygon sphere, you want to have a frequency of 4. You can actually say to this sphere, I want this to be my permanent default. I don't like the way Houdini ships the sphere, and that's fine because you can go on the sphere here itself. And by pressing on the sphere in its parameters, you can go to the gear. And you can say, save as permanent defaults. And what this does is in your home directory, it'll save all of your different parameters, so save as permanent defaults. And you can see it's saved inside of my home Houdini user pref directory. And that's actually $home Houdini 15.5, which will be your user directory as identified on the Windows, on Linux, or on Mac. And then it's going to save in your home 15.5 directory. So be careful every time you want to wipe out that directory, you might have some user prefs in there. Go ahead. And then next time you have the sphere, it's good.
So
yep.
Lucas was wanting to know what are the most important options in skin and scatter nodes?
Okay. We will take a look at skin and scatter for sure. So back to the exercise. So under scatter, you can now see that with the copy operator, we need to basically transform using point operators, but the mountain is actually doing something. So now the mountain doesn't make sense with the scatter. And this is where you start to take a look at the chain, why things are broken, because of where I put the scatter. So we have the normal operator, and then I put the scatter here. And then I do a mountain. Mountain doesn't know what to do on the points, although it is using the point normals. It might be resetting the point normals to 0 because the mountain operator wants to do that. So we probably want to put the scatter operator down here. So you can shake operators off the link, and then you can drag and drop them down, all while holding the mouse button. Now we can put the scatter, and now the copy will be happy. So now we actually have skinning and lofting happening on a crap load of points. Now, one more common thing that I really like to do, and I hope everybody starts getting into the habit of, because at some point in time you're gonna hit a production facility and you'll be working with other Houdini artists, and pretty much all of them will use, again, null operators. Many of them actually have shortcuts defined, and you will label this display render. And what this tells everybody is, even though you've been farting around with the display flags all over, at the end of the day, when you leave this network, it's clear as to what you want to display and render. So when you leave the network, you can do that, and then you can do that. So these are like common things you can do. Now, as for the scatter operator, let's take a look at that guy. Scatter has a whole bunch of different options to it, and I'm always going into the help. So let's do that with the scatter operator. Press the help button. Many of these operators come with example files. And once the help comes up, the help is critical to understand about each one of these operators. As we use Houdini more and more, it becomes how many operators do you know, how many SOPs do you know, and how many have you mastered. And each one of these operators, as you can see, does not very much or does an awful lot. In this case, the scatter takes any input geometry and coats it with points. So we can see that there are a whole bunch of different options, and these options are controlled by the parameters. So we have a whole bunch of different options. But to me, that really doesn't make sense. If I'm learning, or it does make sense, but for me, if I'm learning, I'm going to study a lot of these various different options that ship with these stops. So I can actually launch a brand new session, or I can load. In this case, I'm going to load. If I launch, I'll load a piece of software that I shouldn't be, but I'm going to load. And what this does is it loads it into your current scene. So now if I move my help down and I go up, you can see that it's added a new operator in the tree. Now that's another reason for using the technical desktop is when somebody does something, I know exactly what happened because I can see here somebody's added a new operator on there and I can press on that. And you can see here that it's a door with polka dots. And then I can go inside of here and study this particular network. And if I really like this network and I want to make it more available, let's say I love this network so much that I want to keep on reusing it, I can open up this really cool option inside of networks called galleries. And in these galleries, I can add my own folder. So I'm going to go in here and So all nodes. Basically, I can say in the galleries, L systems, I can store all of these guys, and I can right mouse, and I can, let's say, new gallery category. And I'm going to create a new gallery category, and I'm going to call my stuff. And then, or I can drag, let me just drag it inside of tools here. So I'm going to right mouse on tools, and I'm just going to put it in galleries for now. And there's my stuff right there. So I can drag and drop this whole thing and then drop it into my stuff. And now I've got all those operators inside of there that I can work with if I need to. And or I can take these guys and blow them away. Go ahead.
There's some requests for wanting to cover copy stamping.
Okay, sure. Yeah, we are going to copy stamping a bit later. But I can actually stow these guys and then stow him with the subnet bar. Let me blow that away. And I can drag the subnet and call this the example that it was. So door with dots. And then I can drag that inside as well. So there's door with polka dots. And then I can blow all these guys away if I need to. I need to get used to this keyboard. Where's the lead? Oh, there it is. So so you can put any gallery you want inside of my stuff. So let's go back up. And again, let's actually study this and see where the scatter operator is. And we add all kinds of nodes. It gets considered point scatter. So there's all kinds of different iconic operations that we can do with scattering. Okay. And possibly the most common of all, let's go back up again and go inside up one more directory and go inside of trail grid. The scatter operator, there is a problem in this network. And this is what I want to get to. And then we'll get a couple more questions. The scatter operator, it's doing a ton of relaxing on it. And if I scrub forward, let me close my help, you'll notice that for each frame, or basically, I'm going to animate the mountain. And under offset, I'm going to use this expression called $FF. A lot of you probably have heard or have seen examples of in other softwares users getting all excited because they've done something without keyframes. In Houdini, a lot of the things that a technical artist will be doing will not require keyframes at all. So the majority of Houdini work actually doesn't specifically require keyframes. And a lot of that is because with time we have access to these variables. And $FF stands for floating frame. So $FF in any parameter will return to me the current frame. So when I scrub the frame, you can see that it's now animating. Any one of these parameters can take regular mathematical functions. So if I wanted to multiply this by 0.5 to slow it down, I can just simply type in times 0.05. If we want to see that function, we hold down the Shift key, and then we basically middle click. So hold on the Shift key, middle click on the parameter, opens up the channel editor. And then we can press the H key on the channel editor to home in on that, or we can zoom down using our mouse. And we can see that we have an expression bound to that keyframe. So we can actually see the function as well, if we really want to. But in this case, it's just good enough to just turn it on while you play forward. Now let's take a look at the scatter. We'll have a significant problem that the points are going to be rejigging, and you'll notice that if I start scattering a lot of points, they're jumping all over the place. And let's slow down the deformer even more. So let's multiply it by an even smaller value, 0.05, to slow it right down. So when I scrub forward, it deforms a lot slower. And the points are basically resorting. So with scatter, we can use another operator, and scatter, I seem to be using this operator all the time. So if I tap attribute, there's actually an attribute interpolate. Now, you might be a few users that are familiar with soft and in ICE. There's quite a few options that allow us to create points and stick points on geometry. That's what the attribute interpolate is all about. Now, I want to step back a bit and show you the anatomy of a SOP itself. Every one of these nodes, it doesn't matter where in Houdini, you can query any one of these input tabs by holding down the middle mouse button on the input. So if we do that, we get a hint. I'd say that if you put down a fresh SOP and you middle mouse on the inputs, and by the name of the operator and a quick parse of the parameters, you should get a rough idea as to what that operator might be doing. In this case, the destination geometry goes into the left, and then the source of attributes to interpolate goes on the right. So what we want to do now is the points will go into the left input. That's what we want. So in the scatter, if we take a look on the scatter help itself, it will tell us what we need to do to stick those points, because it's something that's commonly done. So there's some examples using scatter, making scattering points stick on changing geometry, which is what we want to do. Previous to Houdini 14, I think when the scatter got rewritten, we would leave the scatter alive. These days we use the attribute interpolate and keep consistent points when geometry is. So basically here we have skin deforming geometry. So basically we can do, we want to scatter on the static geometry. So let's move the scatter up to here. So now we're scattering on the static geometry. Now you start to see why I like to decouple these operators. Source geometry, and there's my deformer. And then the scatter, it's also asking me to go to the output attributes and turn on these two blindly. That's all I need. Then I'll wire in the deforming geometry into the second input of the attribute interpolate. And what that does is it will now scatter the geometry on the static geometry, and I can use an insane amount of iterations. I can set this to 100. So it's doing 100 iterations of smoothing. And it's only evaluating once. And then with the attribute interpolate, it now will take those points and simply transform them by the deforming geometry. And that's how you make stuff stick. So this is one of these iconic workflows, right? So you can save the scene file. I haven't saved the scene file yet, so I should do that. Let's call this.
Oh, yeah, people want to download that.
Oh, absolutely, definitely. Scatter points with copy. And we'll do that. I've got a whole bunch of other example files that are already documented and ready to go as well. Now, what about the copy operator? Again, we can put a switch operator, but this way we actually know what we want to do. So let's do the copy operator. And now we have lofted skins. Let's actually get this copy SOP under control. The translate is way too far for my liking. And and now you can create some really interesting spiny stuff. My scales are a bit whacked. So, and another thing you'll notice here is that I've got uniform scales. But many times I want to tag the X and Y together, so I can actually quickly do a set-driven key right in here. So I can actually take this and just simply drag. So double-click on the value and drag and drop it onto any other parameter, and again, relative channel reference. And this is the reason why I do a relative channel reference. Is you can see that the path is local, so I don't even need to specify a path. So it's just SX, and if I hover over this parameter, it'll actually give me the name of the channel as SX. So scale SX, SY, and SZ. And if I were to do a full path, so basically I can say paste, copied, reference, and then you get the full path, and that looks really ugly. So as I said, almost all the time I will do just relative reference, and you're good. So now if I change this value, you can see now that I can start tweaking this. And now you can start tweaking things as you want. So, and of course, this is the Z, which is along this is the scale along the spine that I want to change. Okay, and then finally the skin, and then display render. And if I wanted to render this, which is always important to do, I'm always about rendering. Always get a light in there, always get a camera, always add an output driver, and always make sure that you're driving towards something that looks relatively good. In Houdini, the quickest way to set up an environment type light is to use the skylight. And it doesn't matter where I am inside of Houdini. Right now in the tree view, we can see that, I'll just throw this up, you can see that we're deep inside the Terrell grid in this path directory. I can press any one of these tools wherever I want. And let's take a look what happens when I add a skylight, because it's not trivial. So when I press the skylight tool, it actually changed my directory to /obj, and it added two operators, sunlight and skylight, and I can see that there's a dependency between the two. And many times the skylight gets dropped below the sunlight, and the dependency is the sunlight is dependent on the skylight. That's why I always put this above instinctively, and now you know why, because there's that link right there. And then it just adds an interesting environment. It's basically, we'll take a look at what's happening with the skylight because it's doing something interesting inside of it. And then we're going to add a camera, click on a camera. Holding down the control key when I press on the camera inherits my current view. It's a nice thing to know. So holding down control when you click on a camera or a light will actually inherit your current view. And then finally under render, I want to create a render node. And I really do like to create my own render nodes, Mantra PBR. And now if I want to start, and this drops me on the output driver, which I'm not going to worry about right now. By using PBR, it's using physically based rendering by default. So now I can go in the viewport, and we actually have an interactive render view. If we want to invoke that, we can do that by pressing the render view. I had to scroll down there. And now you get a nice render view. And it gives you a nice update. And on the top, we actually have some nice helper things. We can actually run it in preview mode, so we can actually you can point and click as well to determine where the render is, or we can turn preview off if we want. So that's one way in which we can generate a preview render. I'm going to stop that for now by closing the box. We also have a tab in the technical desktop as well as the build render view. And we can satisfy the top by checking cam1, which we added, mantra1, which is the output driver that we added, and /out, again the tree view helping me out, and then I can press the render button. And when I'm pressing render, I can I'm just going to store the spreadsheet for now. I can open these two still bars, and then I can very quickly see what it is I'm working on. Material palette, really handy. Principled shader, there's two schools of thought. Some love I think most artists absolutely love the principled shader. It's based on the Disney shader. Or Mantra surface for the old school guys that want to have complete control over everything. So I can just drag and drop the principled shader on top of my geometry, and then it'll take over. And again, you can obviously click to paint where you want the buckets to be centered to do the rendering. And of course, you can do that. But what's really nice about this is once the shader is assigned, I can go full screen, hold down the control key, and click anywhere I want on this piece of geometry. And it also fires up so once again, holding down the control key and clicking on any rendered pixel will give me the shader for that. And then I can start changing the base color as I want. And start changing the various different properties, increase the reflection limit, decrease the roughness. As a matter of fact, let's go the other way around. Let's increase the roughness a lot, and let's put a clear coat on this. And let's add a coat. There you go. So now we're going to take a bit of a look at, we might revisit the copy swap again to see some of the more iconic workflows, but I'll just answer a couple questions and then we'll move on to the next exercise.
Okay, so in the order that they came, is it possible to find a list of all global attributes?
Yeah, in the help. So the best way to find all global attributes is to go to any old school type node. We haven't taken a look at the point operator yet, which we will in a minute, but I'm going to put down a point operator because there's another thing that we can do to improve this operator. So basically we have the normal. I'm going to plop the point operator inside of here. And if I press the help on the point operator, at the very bottom there's going to be a list of all the generic local variables that are available to us. So if I go to here, so there we are. So these are all the generic local variables available in all the operators.
Okay, next question. What is the basic difference between parameter, channel, attribute?
Okay, so the basic difference between the parameter, a channel, and an attribute. Right off the bat, a channel and a parameter are the same thing, or at least in Houdini nomenclature, they're the same thing. So when we say channel or parameter, we really mean the same thing. But with attribute, that is something entirely different. Attributes, again, just to reiterate, are attributes bound to points, primitives, polygons. And for instance, in this case, the surface normals, which we've now generated and added to our geometry as an attribute. And we can see here that in our spreadsheet, which is another reason why we want to use the technical desktop, you can actually see that I don't really care about these values. Just knowing that the values are there and they're varying is essentially what almost all power users in Houdini just want to see. They're not going to look at 0.54 and see 0.54, you know, or 0.25. Here are these values. Nobody really does that, unless you're inspecting an agent on a crowd, and even then you'd not really care, because we have a lot of viewport options that allow us to see a lot of these data and attributes as we're working on them. So in this case, we can actually see the point normals themselves. And those are attributes as opposed to parameters and channels. There is one thing I want to do, though. And if we take a look at this copy operator, I'm going to simplify it tremendously by setting it to just to one copy. Now, we'll notice that as we're doing our copies, we're in a very dangerous position here. The reason why is because we have not defined a proper frame of reference for these points. So if I scrub forward, you'll notice that the pieces will be sliding and some might be rotating randomly, and depending on what happens, we might actually get some flipping. We can take control over the frame of reference of these points. And I'm going to go all the way up to up in this area here, and I'm going to hold down the Shift key. If you don't know this, holding the Shift key, you can drag on any operator to move a big chunk of that network up. And then I'm just going to move that over to there. And in this particular point operator, I'm going to actually display my copy operator. And I'm going to press on the point operator. And under particle, for historic reasons other than anything else, because it used to be on particles that we would do this, we can add an up vector. Now, up vectors along with so that we now know that in Houdini instancing and the copy operator, which is the same thing, we use the surface normal of the velocity as the z-axis. So if your any geometry is xyz, it'll get flipped so that that geometry's z-axis will match the surface normal. But we need an up vector to lock in that frame of reference. There's many different ways to do that. The most trivial way to do that is to say add up vector. And we do this really very strange thing to you. We put in at up x, at up y, at up z. I have rarely, if ever, used the up vector as defined like this. I'm always using the points up to initialize up vectors. So I will always be right mouse buttoning and deleting channels. As a matter of fact, I do that with almost all of them except for surface normal. And the up vector, I'm going to set this to 1. And as soon as you do that, you can see now all the pieces are nicely oriented going out the up directory. So there you go, nice rock solid up vectors. Okay, and that's what you really need to do with a copy operator. So define your up vector. In this case, I'm almost always initializing it to 0 when 0 or y is up, and then I'll use the surface normals, do my copy. There are other ways of generating the surface normals, but let's answer some more questions.
What does the cache input option on the null do?
So null stops, that's a really good question about nulls because we are using them. Nulls are these great operators in that they're one of those rare operators in Houdini that does not cache its geometry. So for instance, when I use the middle mouse button on this, it's doing some sleight of hand behind the scenes to actually inspect the geometry on the node above it. We've fixed quite a few bugs way in the past that allow this null to behave like a regular saw, but it really isn't, in that it's not caching its result. It's simply just a placeholder node. When we turn on cache input, we now turn it into a real operator. So it now is forced to actually grab the geometry and take memory. So now you can see that the memory is it's 52.21 kilobytes. And let's see what happens when we turn that off. Memory is 0 and it's instanced. So it's now telling you that this node is only taking 143 K, which is minuscule. So that's what cache input does. So if you really wanted to cache the geometry for those rare cases where you need this node to own the geometry, you can do that. Most cases, turn it off. Another question.
Does a null store attribute data so it can be referenced within another SOP or DOP, for example?
Yes, nulls make perfect targets. As I said before, nulls themselves, they don't even own the geometry. And what they will return is the actual geometry feeding into it. And if you have 10 nodes in a row, you can do that as well. They'll all chase up and find that last operator that had real geometry. And it does it all for you behind the scenes. So it's nulls are a great lightweight way of building targets for everything.
Next, what is the default $FF value, a random integer?
No, $FF is it's just a current frame. So $FF is the floating point value. We put that up in the mountain, right? So $FF is just the current floating point frame. And the reason why FF is I don't want you guys to get caught up and not have proper subframe motion blur. So FF avoids that whole problem because it's a floating point value, which means it's smooth between the frames. Next one.
So if you save your preference for a sphere scale to start as 0.5 as default, but you
Yes.
the group bounding button. Yes.
Okay, so that's what it is, yeah. And then what does he want?
Then you would have to multiply by 2 in order for the bound of the object works. No, it's not a big deal, but I think it would be nice to just directly link it when you do that kind of task repetitively.
Yeah, I can see where that is. But if I middle mouse on that operator, you can see that the actual size is 1 by 1 by 1. And the reason why it's not perfect is because it's a polygon sphere. And one of those points isn't quite perfect on the pole, right?
So can you please explain the different prefixes, like @ or $, and when to use each one and the different ways to access various attributes and parameters?
Yeah, so this is the big question. I don't know if you guys saw the VEX webinar I did a few weeks ago. There I explained explicitly when you want to use @. So @ works perfectly in Wranglers, but I still like to use $signs everywhere else. Even though the point operator, when we put it down, will put these @ symbols in here. For some reason, I still like using $signs. Or in this case, we're trying to standardize things to the same nomenclature. So @normal, @nx, and @n.x is consistent with all the Wranglers. But for some reason, I still like using $nx, $ny, and $nz. It's the same thing, and I prefer doing that. So. And then I can say, I can basically revert to defaults, or I can make current values default. So I will usually do that for myself. So right mouse, make current value default. Again, I'm now loading my home directory with all kinds of my own personal preferences. And the next time I add a point operator, it's now going to come up and say @normal, or maybe it won't work there. But yes, next time it'll come up with the NX, NY, and NZ. So. There's a point operator.
There's a question about something changing into float values when you reference it. There's some idea as to why that's useful. I actually don't remember what point that came into.
So that's the one that's highlighted in blue?
Yeah.
Yeah. So why does it change into float values when you reference? It's because it's... Yeah, so let me repeat the question. So the question is from Magnus, is why does it change into float values when you reference? Is there some idea to, can you scroll over? Oh, some idea as to why it is useful. The answer is because it's giving you the result of the very first point processing that particular function. It just tells you that it's working, really. It just says, okay, fine, I've got a value, and I'm working, and I'm evaluating. And that's why you immediately go to the spreadsheet to see what values you have that are really going on. So, I'll just say, okay, fine, it's evaluating to a parameter, but if that parameter is affecting a value or an attribute, we can do that. And in this case, I can see the number of copies. And so just clicking on the parameter shows us the value that it returns or the channel reference that is there. Okay. So.
Next question. Some nodes don't have inputs like font swap, line swap, etc., but they have parameters, text for font swap, for example.
Yes.
Is there any way to control these parameters with Vex?
So this is a great question. So I don't know if people heard it. I'll just repeat it. So some nodes don't have inputs. That's right. A lot of generators do not have inputs, but they have parameters, and you want to be able to control those parameters with Vex functions. The answer is generators by default don't have those sorts of controls. And let's do a little bit of an exercise with a font operator. Display this. And let me turn off the point normals. Turn off my grid because it's getting in the way. So in the question is, can we use Vex to change the various parameters of this font? And the answer is no. Vex currently is not supported in here to change any of one of these parameters. As a matter of fact, with the font operator, we could write Python code inside of these parameters, or we can write HScript code inside of these parameters. But we're at the mercy right now of the local variables of this particular operator. If the font swap has some local variables that we can tap into, in other words, because remember, this is a program that's written to generate a font, I can now go into here and say, look at its help, right? So that's my only hope, is to look at the help and see if there's any local variables, because it itself is a C++ operator. And if I go down to the bottom, no local variables. So we're pretty much stuck with what it is that we have. So other than controlling so we don't have per font control inside the font swap.
Going back to the Magnus question about changing into float values for the reference.
Yeah.
The reference, you meant like that it changes to 0.40001.
Oh, yeah, okay, yeah.
It goes back to 0.4.
So many times when we have, so the question is, and this is a bit disconcerting for a lot of people, a lot of these values that are floating point values, let's find out when that, mountain will have a floating point value. If some of these values, you'll press on them, and you can see here it says 0.565. But when I turn it off, what I'm actually seeing is the full precision of that value inside of that parameter. It's a way that I would say it's an inherited property from the fact that these operators are written in code, and in all intents and purposes, 5.65 really is 5.64999995. But basically, it's a precision issue. So it's just a precision issue with our parameters. That's all. Don't be alarmed by that.
Okay. Next question: is there something like the attribute interpolate node in Houdini 13 as well?
Attribute interpolate? No. Attribute interpolate got introduced when the scatter swap got rewritten in Houdini 14.
Get 15.5.
Yes, Fiona said get 15.5, which I wholeheartedly agree with. And yeah, so scatter attribute interpolate was introduced in 14, I believe, and it's a great way of sticking stuff on other stuff. In this case, point clouds. It's great for whiskers on characters. Grass on terrain that's changing, sticking barbs onto deforming geometry. Let's say you have a cloak that you want to trail some points, which is what I want to do next. And there's a few other exercises I want to get to next. So, more questions?
Yes. Is there a way to make those scattered points stick on a deforming geometry if the geo is deformed in another 3D package?
Absolutely.
For example, an animated character.
Yes. And so I'm not on my local machine. But that's the great thing about this deformer here is somebody said, well, will this work? I'm in Houdini. I want to know if this will work on deforming geometry from another application. And the answer is you can answer that question yourself. And this is a really quick 2-minute exercise where we're going to test that out. That's why I have the null deformer, because that means anything that's deforming, whether it's deformed off a disk as a cached geometry or not, it doesn't matter to me. So let's cache the output of the mountain up. And we actually have a really cool node called the ROP output driver. ROP stands for render output. Output driver, yeah, okay, so we duplicate ourselves. It's got a side chain, which tells you that it's uniquely different. And we can export out of here a sequence of geometry. So hip geo, and what I'm going to call this hip name. Basically, this is just a bunch of environment variables preceded with dollar signs. Hip name, which will return the name of the file, which will be this full name, or the name of the file, which in this case is scatter points with copy. But I'm going to blow this all away, and I just want to call this. I don't want to leave the $F, by the way.
You can also do OBJ, right?
That's right, deform geo, and we can output this in a whole bunch of different ways. Because we're in Houdini, we can use bgeo.sc, and let's do that first. So actually, let's actually do this as OBJ. You can actually put OBJ. And how do I know all the extensions? Is I'm just going to render that. So render frame range 1 to 240, and let me save. I always like to save before I execute any things out the disk, and I say save the disk. Now what that does is it's now writing all of my geometry out the disk. So, and I could have actually done save to disk in background and continued on working. I don't know why I pressed save to disk. It's habit, yeah. So, and it's going to be writing all of that stuff to disk. So as a matter of fact, I'm going to interrupt that and file save and actually do that in the background. Save to disk in background, erase and replace. So now it's working away. And I can open the scheduler if I want, and I can actually see that it's done. Okay, so now I've got my output. Now I always like doing this. I put a file operator right below it. And in the file operator, I can even do this. I can copy this and say copy parameter, and then go in the file and do paste copied relative reference. It works with strings as well. We're going to talk a bit about HScript if we have a chance, or maybe we'll save that for another lesson, or I might do some lessons on my own on HScript. But for now, Fiona says, no, let's not do HScript, so we're not going to do HScript. But basically, this is actually Houdini script. And now we can put a switch in here. You'll notice that a lot of the operators that ship with Houdini, whether you know it or not, are doing this. So we actually have a file cache operator, and the file cache operator does all of this in turn. So the file cache allows me to drive, so I can actually do it this way, and now I can switch between the second input. This is now equivalent to loading those OBJ files from disk, and there's my output deformer. So you can test it yourself. And if you want to see those files, you can press on the file operator, load that up, and you can see here we have this really nice file browser in Houdini where we have this convenience operator that actually concatenates all of the files into a single entry, or we can see them all. Those are OBJ files. I mean, you could load them up anywhere you want, games, any other applications. So we can actually generate, so you can test this yourself and prove to the fact that it's that. And again, I'm just highlighting why I like putting this thing called out deformer. Anything I want to do, it's a deformation, whether it's, as I said before, any screwy way that you can deform geometry, Houdini can handle it. And but then again, stepping back to file cache, so if I put the file cache in here, and then I press on this guy. And all I need to do, I'm just going to copy this expression, Control C that is, and then Control V that into here. Now the file cache is designed to replace this workflow. And it's always good to know what's happening behind the scenes. So the file cache, and let's go to switch back to 0. The file cache now allows me to load from disk or not. So, but take a look at the tree view. Another thing about Houdini is it's really hard to know what I'm looking at. But with the tree view, I can see here, why did this file cache have a plus button on it? The answer is because it's a subnet node, and it's also a digital asset. So if I open this up and I dive inside of it, there we go. There's the output driver and the file operator. So we have a lot of these really nice nodes that encapsulate a lot of workflow. Sure, you can do this sort of a workflow and bust it out and have complete control. But over the years, we've added so many more convenience type operators. You'll notice if you tab file, though, we still have file. You might go to that first. You have file cache and file merge. File cache is the one that you probably want to be using all the time. So that's that. So yeah, test OBJs. You can basically, again, that's why I always put out deformer. So more questions, or I want to go to a simulation one.
Let's do simulation.
Yeah, I want to jump to a simulation now. And so I'll save this file because we can be at this all day. I love doing this. So one of the things that we're doing with simulation, and this is one of these low-hanging fruit, we're going to do a simple power explosion. But in the power explosion, we want to be able to direct the explosion. So I'm going to start off by opening up a file that already does that. So power example, and you'll find that a lot of these examples and exercises, users from other applications have amazing examples of code, script that they've learned, and time on, oh, I'm actually getting a nice render reference. Time hard-earned code bits, and they want to be able to see if they can do those inside of Houdini. That's great, but you don't realize that in Houdini there's a lot of nodes and operators that are probably more efficient at doing the same thing. So again, you want to get past the basics of Houdini and get down to the nodes themselves and understanding every node. So what is it that I want to do is, you'll see here I have a nice emitter that's got some nice curl noise that uses a magnet operator, and the magnet operator, I can actually move this magnet to sculpt how I want those velocities to work. Do I want it to push to the left? Do I want it to push to the right? I love using magnet operators to create local fields of influence. I know there's lots of expressions that you've probably seen in many tutorials. If you started to learn Houdini, I just like using magnets because they're really straightforward. And the killer combo, and there's always killer combos in Houdini, there's the meta ball and the magnet. And then whatever geometry I put into the left input, which if I middle mouse on it says, so this is the stuff to deform. And the right input, middle mouse, is the magnet operator. So I like this killer combo all over the place. So let's see if we can work this up from scratch. Oh, by the way, we can actually see the explosion. I should show that really quickly. What the result, which we should get at, is now when we press forward, we can blow the explosion wherever we want really easily. And it also gives us a lot of directability. And this is a great example to get to grips with what do you do beyond the shelf tools. So I'm going to file new, discard new. So let me turn my ground plane. Now I want to start off with a tube. Sphere tubes, whatever. A lot of our tools are designed to work with geometry that comes off the shelf. The assumption is that let's set the height 0.2. I'll make it a bit more of a pancake. So a lot of these times we're just the tools are designed to work with primitives that are roughly half a meter to a meter and a half to 2 meters. But be aware that all of our simulation tools are designed around meters as units. So if you've got a tremendous amount of very large geometry, it sometimes might come in with much too high a voxel count or whatever. But chances are just go for it and see what happens. So we're going to go straight to the Pyro shelf. Again, in the technical desktop, now when we press a tool, we're now aware that whoever wrote this tool is going to create a tremendous amount of nodes and then teleport me somewhere inside the scene. And teleport, I really do mean that, because some of these operators can even create a composite network and teleport you there or into the simulation environment. But let's see where the explosion lands us. And let's watch the tree view on the left-hand side to see what happens. So I have my tube selected, and let's actually call this fuel. Call this fuel source. Now we're going to press explosion. And the explosion tool is takes my current selection, adds a fuel, and then press forward, and we get immediate results. I mean, that's the great thing about shelf tools, is you put them down, you play forward, and then you get something. But if it doesn't give you what you want, what do you have to do next? So when we press the explosion tool, you can see that it created a tremendous amount of operators. And it landed us right in the middle of the sim. Not only that, it selected the PyroSolver node for us, where we can start tuning some of the behaviors of this simulation. For instance, the buoyancy lift, which controls the amount of velocity based on temperature going upwards, or the time scale, which is the speed of the simulation. We can see that we're actually reducing the speed of the simulation by 35 or 45, 35%. Yeah, 35%. And temperature diffusion, which is basically blurring the temperature field. But where I really want to go is the source. So in DOPS, it's a completely different type of a network than geometry is. You always get these killer pairs again, which is going to be the source geometry, the object that initializes the simulation object, and then the solver that that object is bound to. If we take a look, there's other inputs. And again, middle mouse button tells us what these inputs are. There's a pre-solve, there's a velocity update, there's an advection, and then finally there's sourcing. And that's where we're actually providing all the source fuel for our simulation. And in this case, it's actually pointing to a SOP. So, and this is what's actually picking the geometry up from other part of the scene. And we can actually slash OBJ again. Now we go slash OBJ slash fuel source out one. Or we can press this convenient jump button. But if I hold down the control key, it actually gives me the SOP's parameters if I wanted to. So that's a quick shortcut not too many people know about. If you hold down the, or if you hover over it, it actually tells you control plus left mouse button, open parameters pop-up dialog. But I actually want to jump to that network. And here is my tube. And this is a classic Houdini operator. Whenever we run one of these tools, there's no scripts. So the tube is a polygon, which is fine. And we have a node called here fluid source. And fluid source is a digital asset that takes any manifold geometry, anything that's closed, and builds us volumes. In this case, volumes that are suitable for using as a source for pyro simulation, for example. And so there's my fuel. I'm actually going to change my background to black. I just hit the D key or the I to open up the, and I'm just going to go to the background and I'm going to set it to dark. Just so we can see that and turn off my construction plane for now. So the fuel volume, this particular operator is pretty clever in that it's trying to build some source fuel. But I want to take this original tube and I want to add a lot more geometry to it. So basically I'm going to subdivide it. And by subdividing it, it turns me into this cube. And what I do is I just override the crease weights, and I can increase the crease weights. And as a matter of fact, if you match the depth with the crease weight, you actually get perfect solid. So let me just drag and drop relative channel reference. You guys should know that by now. And now I just got more points to play with. And or I could use a scatter operator as well. It really doesn't matter at this point. But in the subdivide, now what I want to do is add normals. Again, put on a normal node. And in the normal node, I just want to add point normals. And now I want to add a metaball and then a magnet SOP. So that's the potent pair. Middle mouse, so I want to put the magnet in there, and then wire that into there, and then wire that into there. So now I've knitted in these two nodes that work very well together. As a matter of fact, they work perfectly together. Now the magnet operator takes whatever metaball we have and applies, in this case we can scale it up, or we can translate it upwards depending on how we want to deform it. So you can do some pretty nice organic things. But in this case, I want to just simply scale it outwards. And let's set it to something a bit bigger, let's say something like that. And now you can see that if I press on the metaball and I hit the T key, I can now start deforming this geometry. So this is fully keyframeable. I can keyframe this magnet and I can deform my geometry. But the magnet node does a lot more than just, and I said before I wanted to push the geometry off to the side, so let's do that. So in the magnet operator, I can go to the Attributes tab. We have all kinds of really interesting options. Affect the position, or affect the color, or affect the point normal. And if I turn on my point normals, you can now see that it will affect the point normal. So if I go to the metaball and I push it over to here, you can see now that I can actually move the normal. So if I put the sphere over to there, and then I go to the magnet, and I can now start changing the strength of the scale. And I can start blowing those normals however I want. I can change the radius of my metaball. So change the radius, and I can do that via the scale handle as well. So if I have the metal selected, I can affect the scale. I can use these nice scale handles. And now you can see that I'm really blowing that velocity apart. So this allows us to control the velocity vectors in a very artistic manner. I use this all the time, so there's no need to write expressions to do all of that. Now we have the fuel. And if I middle mouse on this, you can see that the way that this guy works is, and there are assumptions on a lot of these operators, it's looking for a velocity attribute. So if a velocity attribute is present on the points, it will use that velocity. Or you can go to the velocity volumes, for instance, and you can add as many velocity volumes as you want in here. And you can visualize the streamers, you can change the various parameters on that. But in this case, if we add velocity inputs into this guy, it'll actually create the velocity fields. Right now it's only building fuel and temperature. So we need to take, and in Houdini by default, we can add an attribute lowercase v. And for that, we can actually put down an attribute rename. And the attribute rename allows me to rename attributes. I have to use my middle mouse button now to move what is now capital N to lowercase v. So I can say attribute from N to lowercase v. And as soon as I do that, now everything kicks in. And I'll put a note in here. And I like doing this. There you go. So we can build velocity volumes, I'm sorry. So now we got some really nice velocity. This is done all the time. So, and this is what people call about customizing fluid solver. So you can customize the velocities coming into this and do whatever you want. Just knowing this one technique, and by the way, this works everywhere. So this lowercase v velocity attribute is used on all solvers. As a matter of fact, it's even used with the copier operator in place of n, so it's very important to know that. And now I can add some really cool noise to this velocity. So if I go to the curl noise, for instance, always add curl noise. And now we're adding some nice noise to the velocity field. And I could be playing forward as I do this, and then you can see that we're creating those really. You can see how the curl noise that we're injecting into the fluid simulation really takes control over the behavior for the first few frames. And then the simulation kicks in. So depending on the type of curl noise we add, we can change the scale, the amount of noise that we want to put in there, plus the pulse length if we want to increase or decrease the pulse length, or the swirl size. Let's make the swirl size a bit smaller because we want to add a lot of fine detail. And then we can decrease the grain, which is the roughness of the noise, or increase the grain. It's up to you. And then finally, if we press forward now, we're now going to get re-injecting that really cool. And you can see that it tends to break it up a lot more now. We're blowing our simulation off to the right. Now, if we're doing it too strong, so that's the exercise of this guy. So file save as. There we go, metaball. Let's press that. So I have a more involved example of that set up. So more questions on this one.
What's the definition of a streamer?
A streamer is it's just a visual guide that we render into the viewport that allows you to see the velocity as it's advected through a velocity field. So to answer that question properly, so what are these streamers? And we'll show you how to use them quickly in SOPs as well. It's a good question. So the Pyro solver, under the Pyro object though, we actually have some options. So under velocity, I'm going to hide everything else. We can actually see here we also have velocity streamers as well. And they're just ways of seeing the current velocity as it gets pulled through a velocity volume or velocity field. That's all that is. So in the case of the Pyro solver, if I open up the spreadsheet, in the Pyro object itself, the spreadsheet now starts to show me what are my simulation objects. and then all the data bound to that simulation object. If I scroll down, one of those is a velocity field. And that velocity field can be used, we use the word advect, but you can think of it as being pulled over time. So you can pull something through a velocity field over time. So that's it in the pyrosolver. But in the object itself, the same thing is happening inside of the fuel volume. And what the node it's actually doing is we actually have a volume tool called volume trail. And volume trail takes two inputs, points to trail and velocity volumes. So this guy actually has velocity volumes, so we can actually build our own trails if we want to as well. If we don't really want to work with that, there's a node for everything. And of course, this is the points that we want to trail through. And there we go. So in the velocity volumes, I can actually pick them in here, val.star. So we can build our own trails.
Is it possible to export the data for the streamer splines and use them somewhere else in Houdini?
That's what I just did.
Okay.
So the question is, great, how can I use those streamers? How do I recreate those streamers? And the answer is done all the time. As a matter of fact, no matter what simulation we do, and I'll show you a bit of a rigid body simulation next, because I always put an empty low resolution velocity field in there, as a matter of fact. And then what we get is these really cool velocity fields, very low res, that we can do stuff with later on, including volume trails. So right now, middle mouse on the volume, it shows me I've got quite a few points and some volume fields. But what this operator is actually doing is building real curve geometry. So we can see here that we got 290 polygons and 290 primitives. It's the same thing, and a total of 5,138 points. Now, this is real geometry now. I can turn on my points and I can actually see I've got streamers. A bit rough, but we can do a lot better than that. So a lot of times people will like to render these as curves. Oh, by the way, I'm going to add a render operator because Houdini can render open curves no matter what. So if we go to render node mantra PBR, and then let's add a camera, control click, and so we're all ready to render now. And let's add a skylight just because it's a quick way of adding a light. And now I can go back into my fuel source, and there's my volume trail. And these are actual curves. So now I can actually hit the render option in here, and you'll see that they'll actually have a width associated with them as well. Really, really tiny though. So what I'm going to do is I'm going to go up here and turn off my power sim, fuel source, and now I should be able to render these guys.
Question about the controlling the amount of fuel, like with an explosion, is there a huge amount, like there is a huge amount at the beginning and then it dies?
Yeah, because that's keyframed. We can take a look at the pyro on that as well, but polyspline allows me to, just getting back to the polyspline. Polyspline is just one of those nodes that you use on curves. And what it does is it just allows you to use the base curves and just makes them smooth. As we can see here, the volume trail is very rough. And if we put them through a polyspline, it just creates nice smooth curves for us. And we can control the amount of resolution that we want. As well, the number of trails that we want to generate, you can increase the trail length or the advected length through the volume field, so we can animate that. And the maximum number of steps, we can actually increase that as well. Or turn the visualize velocity off and just end up with curves. Yeah, so that's a really great node for just generating streamers that we want to render. So what's the question again? It's
hold on, sorry. The question about controlling the amount of fuel.
So fuel, when you're working with the shelf tools, explosion, fireball, they'll all have animated under combustion, it's going to be animated gas released. So it's going to take the fuel, but by animating the gas released, and if you know anything about the pyrosolver, gas released is what controls the expansion rate. And so that's, in fact, what's driving almost all of the explosion itself. So if we shift click on this, you can see here that the gas release goes from 100 to basically 0. So that, or pardon me, to 14. So that's the expansion rate of the simulation. So that's what's driving all the behavior. And the source fuel is also animated. Shift click on that, and you can see here that somebody spent a lot of time crafting this fuel. So this is completely keyframe animated control of the source. So and that's what you get off the shelf. So the shelf gives you really nice behavior for basic simulations. And yeah, you can change that and keyframe however that you want. Another question?
Can you show how to render the blow_pyro with metabol's sim so it looks very realistic, like a realistic fire, or give some hints as to what to look for to do?
Oh, so you want to do a realistic fire?
Maybe we should do like a pyro.
Yeah, we should do a pyro session. Absolutely. Yeah, we can do a pyro session for sure. Yeah, it sounds to me like there's a lot of questions about pyro that we can deal with. Yeah. So I'm going to go back to my notes and to make sure that we're on track because I have a lot of stuff. Okay, I want to take a look at some attributes now, painting with attributes. Many times we use attributes to do all kinds of cool stuff with regards to terrains and fracturing terrains or identifying areas that we need to work on to deform and destroy. So I'm going to take a look here at animated attribute weights. Okay, so this is your typical example of a Houdini file. And to step back, and I really do mean this, is that this technique of putting attributes, whether I'm using metaballs or painting or blending or using really fancy expressions, is essentially just creating an attribute on some geometry that we can then use to do stuff with. And again, remember in Houdini, an attribute is like color. It's a surface normal, or it can be any attribute that we want it to be. So this is a really great example where I can actually, let me turn on escape here, deselect all my operators. I think I got wireframe on, so I just want to do smooth shaded. So I think I got a template flag on here. I'll turn the template flag off. So in this particular case, taking some geometry and I'm simply wiping a normal on it, and I'm keeping that normal, I'm keeping that color around. So we're going to build this up from scratch, and then we might fire up this file. Again, depends on how quickly I can get this done. But this is using a really basic technique. Again, I like my metaballs to test stuff out. So we have many different ways of taking a grid, and then we remesh it down to here. In this case, I chose to use the remesh based on fracturing, and then we can add a color attribute, add some normals, and then there's our magnet with the metaball. So we can actually use a magnet to visualize where it is that we're going here. So space W. And of course, the magnet can also be used to deform the surface normals, which is what we're doing, as well as the color as well. So it's whatever we want to affect the point normal if we wanted to. In this case, I wasn't doing that, but you can affect the point normal as well, color, point position, whatever we want. So it's a great way of deforming the geometry. But what can we do with that? And I'll show you how we can use that to basically create a cracked attribute with a primitive operator that we can then do other stuff with. So let's do that one from scratch. And then we can see all the gotchas. So I'm actually going to change my mode to select. There we go. I've still got my render window up there. Well, that always. Is it okay? Can people hear me now?
Audio is back.
It says the audio was suspended, and I was wondering what the heck was that.
Okay, rock and roll.
Thank you. So we're starting off with a grid, and we want to wipe some attributes on this. So let's actually go right to the magnet swap and the metaball swap. And the metaball swap, we can then drag it onto our geometry, and then the magnet will bulge the geometry based on the metaball. If we put a scale or a translate, we could translate it up if we wanted to. And the shape of the metaball will determine the shape of the effect. So if we want to flatten it out in Y, we can do that. Or we can change the weight of the metaball. I usually leave it at the default of 2. But it's the magnet swap that's doing all the work by taking that right input metaball magnet and then deforming our grid. The problem we have is with a lot of these operators, you say affect point color. The word affect actually means affect incoming point color. It doesn't know itself how to create point color. So if we turn that on, we can see in the spreadsheet it just initializes all the values to 1 because it doesn't know what to affect. It's actually affecting the color by 1, but it initializes it as 1 as well. That's just one of the default behaviors of Houdini when we initialize color. So what do we need to do? We need to put down a color swap to add some color to our geometry. And we're going to make the color black because it's very common to do this. So if you want to use color as a way of deforming geometry, which is a very common Houdini technique, you can absolutely do that. And that's what we have the color swap for. Middle mouse on the color, confirm that we have a point attribute in this case, and then the spreadsheet, we can see we got some values. I'm seeing lots of green, so you can actually press on the value of the spreadsheet to see if there's any value, pardon me, on the magnet swap that is. And we can see here that we actually have a value of about 0.5, which probably coincides roughly with the translate value that we have, which is sort of close. So we know that we're affecting the geometry in the Y direction. And if we want to do other attributes as well, such as the normal, but this is all we want. So now we have this magnet. If I turn on the construction plane, which is on, I can now move this magnet wherever I want. And we want to keyframe this guy through our grid. So let's start him over here. I always want to see something, so I'm going to keyframe, you can tap the K key in the viewport, or what I like to do is hold down the Alt key and then click on the center of the metaball. And as a matter of fact, might be wiser to use a transform on the metaball. So I'm going to undo that, Control Z, and Control middle. By the way, Control middle mouse button on a name will actually initialize all the values to 0. And let's put a transform node on there. I always like a transform node to animate all of our geometry. And now I can, with him selected, I can now go in there and I can just alt click. And let's go to frame 15. Let's move him over to here. And let's alt click that. The second time we'll key all the parameters. And then let's move to 24. And let's wipe this guy right off the terrain. And again, hold the Alt click down once, and just force keys on everything. Alt click again, and now when I scrub forward from frame 1 to 24, we're actually going to get some frames. And I'm going to change that to 24, just so that we're scrubbing over the frames from 1 to 24. So that's fine. Now we want to use that green attribute. So if I press on the magnet, you can see that we got the green attribute. It's varying across the green. So I can actually put down a primitive operator. And this primitive SOP is one of these iconic operators that changes any attributes on a primitive. If I say do transformation and I scale it down, I can scale down the primitive size, and what this will do is it'll try, each primitive in itself is trying to scale down, and it'll suck itself to death, so we don't want that. But it's iconic workflow to do a couple things prior to a primitive if we want to shrink things down. The first one is to put down a fuse operator. Fuse or weld, I know other applications call it weld. But what we can do is we can unweld or unique all the points. And now when we go to the primitive transform, if we zoom in here, you can see here that now if I scale down, you can see that we're now shrinking all the polygons down to nothing. That's great, but it doesn't look like fractured terrain. So, and by the way, let's actually now worry about our grid. And I'm going to go straight to the chase. And under the grid, under modify, under model, we've got a great shatter tool. It's great for shattering blocks, objects, spheres, buildings, whatever ground, solid ground. But I'm going to put the shatter tool. And what this will try and do is it'll build. So the shatter tool off the shelf gives me these three operators. And what it's doing is it takes a grid, or it takes any input geometry, and it tries to convert it to fog. The problem is it's trying to turn the grid into a fog object. And that may or may not work. And then we have a scatter operator that scatters points inside of the volume. But we're dealing with a grid. So I know the slight shorthand trick, and Houdini's full of these little tricks. I can bypass the convert to fog. And now I'm scattering points on my ground. And it's these points that are used to fracture my geometry. So now we're actually fracturing the geometry. Oh, and we're actually fracturing it on a huge resolution. So let's set this to 2 by 2. So now we can see here that we fractured our geometry. So now it's just a matter of increasing the total count of polygons until I'm happy. And that might be good for what I'm doing. Let's back it off a bit. So now I've fractured my geometry. I'm actually pretty much just reconstructing my geometry. Now I'm coloring it again. So remember, the magnet is doing what it's normally doing. Fuse, and then primitive. And now if I do the primitive, it starts to look a lot more interesting when I start scaling it back. The problem is I'm scaling every primitive everywhere. So now what I want to do is turn to the help. And again, this is all about operators. Learning the primitive SOP. The first place you go to is go to help. You saw, oh, Jeff, I saw it. He's shrunk polygons. I don't know how to do that. So the answer is you can watch the video, take a look at the files, look at the help, and see if you can get some clues. There are local variables on the primitive. And that's where I'm going to scroll right down to right now. So basically, if there's a primitive attribute on anything from volumes to NURBS to polygons, it can affect it. But what I'm looking for is here. Check this out. It supports color as a way of scaling primitives. Why? Well, I think it was in 93 or 94 we added this behavior for a specific effect. And this SOP people have been using $CR, CG, and CB inside the primitive SOP for years. So inside this local, there's these so I can access the color red, the color green, or the color blue, or the alpha color, and use it to drive any parameter I want. And all I need to do is precede that with a $sign. So if I want to grab the color green, I would put $CG. And let's actually put $CG into, and you can see here we even get some help. And if I do that, I now get the color green, and take a look at that. I'm now scaling it based on the color green. So now I can take this, Control-C it, and Control-V it into the other two. Oh, I hit Alt-Key. I'm used to the Mac. Control-C. I also got a really cool keyboard that maps out the same way as the Mac on Windows. So. But anyway, so now look what's happening here. And we're going to explain why. CG is 0 everywhere else because we set the color to black. So we're initializing our colors to black. We can spell that correctly. And now down below, we're using the primitive to scale it. So basically, it's scaling everything to 0. And check this out. Houdini's not crashing. We actually have 0 size primitives. Back in the day, Houdini might have crashed, but we fixed those issues. So you can even do nut bar things like scale primitives to 0. And Houdini says, fine, you got 0. And you go, where'd my geometry go? Turn on your points. It basically sucked them into nothing. We want to get the exact opposite of this. So we want to do, we know CG is going from 0 to 1, but we want to go from 1 to 0. So if we've got, let's do some little mental math here. So we want where 0 to be 1, and we want 1 to be 0. So do 1 minus. I think this is grade 5 math. So 1 minus. So by looking at our inner 1 minus, so you can actually write mathematical functions in here. And then, oh, if I can do things right here, 1 minus $CG. And now you can see we're now scaling based on that value. So as I press forward, now I can take those points and I can do all kinds of work to it. Now from here, it's up to you. What do you want to do? Do you want to run a rigid body simulation? Do you want to do all kinds of generate some particles based on the green, release these pieces, or do you want to just leave it in SOPs and do some really interesting type of work? So the transform is boring to me now, so I'm going to turn off the position. I just used it to just temporarily see what was doing. We understand what's happening now. And as I scrub forward, we can see how that metaball is wiping through our terrain. The problem is it's not persistent. So I'm going to show you basically how to do that with the SOP solver.
15 minutes.
And the SOP solver, it's one of these things as in Houdini that says, this is as hard as it's going to get. If this is as hard as Houdini's going to get, this is as hard as Houdini's going to get. And I'm really honest when I say that. I've been using Houdini in a way that most every Houdini user in production would be using it, no different. I like using metaballs to preview stuff, and then I might put some other expressions on top of that or build different systems to do that, but they work great. So now what I'm going to do is put down a SOP solver, and or the solver SOP, I'm sorry. And this guy is pretty cool. What it allows me to do is I'm going to put this in a way that allows me to control the attributes. So the primitive SOP is what's doing the work. So I want to do this upstream, and this is the biggest difference between us and pretty much all the other software out there, is that you actually have the opportunity of changing things upstream and having operators below process those changes. It's a fundamental concept of proceduralism. And we really haven't talked about proceduralism because there is no thing that procedural is. Basically just an approach, a technique. Everything we've been doing up to now has been procedural workflows where we can change things wherever we want, mix up the recipe. So we've been really doing procedural workflows the whole time. Non-destructive, I might add, because we can change pretty much any parameter we want. But the solver SOP, I'm going to work that off to the side. And the solver SOP, what it's doing is it's freezing into the current frame. So we're going to dive inside the solver SOP. It is a subnet, as we can see in the tree view. We can dive inside. And currently, the display flag is on the previous frame. So in other words, it's giving me the previous frame. And the problem is, if I play forward, the previous frame it will always be the first frame because fourth is looking at the third, second. So in other words, it is a solver, and it looks at so frame 2 is looking at frame 1, which then carries to frame T3, which is looking at frame 2, which copied from frame 1. So it's a true solver operator. We're going to break that up. And what we're going to do down is we're going to put down what's called a wrangler. Now wranglers are great, and you can watch my Vex Wrangler intro on that, but I'm going to actually put down the current geometry into there and the previous frame into there. And we're going to write a really, really simple expression in here. And it's going to be really clumsy, but it's going to work. And so the $ versus @ signs. In wrangling, we don't use the $ to access an attribute. We use the @ symbol. And if we press middle mouse on the previous frame, we can see that we have CD. And it's literally that name CD. So I put @CD plus equals, and I'm just going to add in the previous frame. But I need to access the previous frame. If you take a look at my Vex lecture, you'll realize that to get the previous frame is or you have to do V for vector, op input 1, which is the second input, because we count from 0 in programming, and we want to pick the attribute CD. by doing this one thing, what we're doing now is we're saying that the current color that we're outputting, which we're picking up from the current frame, we're adding to the previous frame. So that means CD is going to run out of control, but we really don't care. What we want to do is now run up the color. And there we go. So now we have persistent green. And this is as complicated as I'm going to make it right now because, as a matter of fact, let's do one more thing. Let's take a look at the spreadsheet and let's go to frame, let's say 6, and let's take a look at the green. We can see that every time we go up, those values will increase because remember, we're just simply accumulating all of that color. So by rights, what we should really do is we should clamp CD. So we actually have a clamp function, so at CD equals clamp. And I know clamp takes the value that we want to work on at CD, and we can clamp it to 0 and 1. And so now our values will be clamped at 1 no matter where we go. So it's really nice to always normalize our colors at 1. And now we can wrap our color. And like we did before, let's put a switch operator in there. We don't really have to, but I like putting switches in there because it's a good idea to always use switches because you can try many different options on it. And then we can see here that the color is wrapping through, and let me display my switch. And, oh, because the switch has to go to 1, that's why. And now when we wipe forward, we're now going to get persistent scaling down. And it's 1 minus CG, so, oh, great, Jeff. That's good. That should be just, oh, there we go. I don't know why that operator wasn't cooking, but now it is. So now they're scaling down to 0. Because remember, our green is going from 0 to 1. So if we don't want that, we can, after this, put down another wrangler. And we can now take the wrangle the CD. So we want to take at CD, let's say, times equals 0.5. I just want to cut it down by 0.5, and there we go. So now the solver is putting out color guaranteed to between 0 and 1. I love normalizing things. Always important to always go from 0 to 1. And then later on you can modify that prior to going into the node. So there you go. And if you want to put an interface onto this 0.5, we're going to go full circle. We saw a bit of that CH function when we were looking at channel references. Inside the Wrangler, we can actually do this, and we can actually put our own, let's put it color scale. So we can do that. And we can put this inside of double brackets just to be safe because it's a string. And then we can press this button over here, which will turn this channel expression into an actual slider. And now I can take that slider and I can scale it. And again, that's all using CH as this channel function. And I'll save this file. Call this fractured ground. So the whole idea here is this is the foundation for so many different types of effects. We can use the color green to generate particles from. I mean, the particle node can use any attribute to determine the density. We can use this to determine what falls over. And as a matter of fact, it's very common to do a fuse operator afterwards and then weld together everything that is within a specific distance. So basically, you know, if I want to select this piece here and I say select connected, I can now see there's my whole island. Whereas if I go up into here, you can see they're individual pieces. So I can even fuse to weld stuff up again, right? Weld non-modified. And that's how you do things. So that's sort of thinking a little bit out of the box. So
Beautiful.
I'll go back to polls and some more questions.
So here comes a poll on which of the following webinar topics are most interesting to you. Let's do it.
Okay. And while you guys are doing the poll, we'll take a look at a couple more example files, and then we'll answer some questions. Okay.
Okay, I'll read it from backwards, most recent. Wouldn't you want to preserve that value and clamp outside of the solver?
Oh, absolutely. So the question is, wouldn't you want to keep that accumulated value and then clamp it afterwards? And the answer is you could absolutely do that. I could actually clamp it up in here. But what I would do is you're now starting to go, okay, I got some director, so you're the director, you're telling me I did it wrong. So the answer is I'm now going to create my own attribute. So I'm going to put in here v at my cd, or what I'm going to do here is something quite interesting. So I'm going to put in here v, let's actually make it a float at my val. I'm just calling it my val because I'm making it up, or let's call this weight, my weight, equals at, and I can use a really cool function. I hate to say this, but Pythagoras length of a, we can just use the length. We can actually calculate the length of a color, and it gives us the magnitude of that color, which is what I like to do to turn any vector into a float, to know its weight, its magnitude, its length. So at CD. So that's probably the best way to do it. Now I've got my weight set up to do that. So now my weight is now set up to take the length of the color. And now there you go. And it's now living outside of the clamp value. So, and that's the answer to that. So. And as you said, you can do that, or I can do whatever I want. Or as the accumulator, or let me, hold on, you're right, because the accumulator is not doing the right thing. I can now, I can add another attribute for the so call it vect at cd unclamped, unbound equals at CD, and then actually put CD clamped. I should actually do this. Actually, I'm going to do. Actually, you know what I'm going to do is the easiest thing of all: CD clamped. I'm thinking on the fly, but anyway, so there's B at CD clamped. That's probably the best way to do it. So that way, color is constantly increasing unbounded. And then it's getting written to CD anyway. Then I have my weight, which is the length, and then that clamped color as well, which is unclamped. So there you go. Hope that helps. And now it's going to go down to smaller values. But anyway, there you go. Okay. So it's just refactoring stuff and always thinking about things and using the spreadsheet all the time to see. And you can see there's all my attributes now. There's my weight. It's the clamped weight, the unclamped weight, and then there's the regular CG that's being accumulated. So.
We've got 2 minutes in the official time, but we've also got a lot of questions.
Okay, let's see how many we can deal with.
Okay, let's go backwards. So you can control the parameters of a font with expressions or vex. What exactly is the difference between complex expression and vex?
So we can. So the basic question is, what is the difference between a complex expression, or just simplify it, an expression versus vex? An expression is limited to the field that we're working with inside of SOLPs. That's pretty much what it's used for. So let's take a look here, file new, because I think I have a really quick example that we can fire up for that. So again, let's put down a sphere this time. Dive inside of it, and let's just make it into a polygon. So if we have, let's put down a point SOP, and we're going to put down, which we haven't taken a look at. We're going to put down 2 other operators. One's going to be a wrangle VOP. We could put on an attribute wrangle, and the third one's going to be a wrangle VOP. But put down an attribute VOP. I'm sorry, an attribute VOP.
Just quickly, Jeff, there's a lot of people that have to leave now, so just a quick poll on complexity level.
Sure.
So.
Yeah, because it's hard for me to figure out what's.
Absolutely.
Yeah, it's really hard for me to know what to do and what to talk about.
And also, there was a question about what happened to the QA stuff from Beck's webinar.
It'll be out there end of today. Yeah,
I
I'm
think
almost
we're
ready.
Do the same thing today for the questions today. Maybe?
Yeah, we can do the same thing, but I'll answer this one because it's really important because we haven't taken a look at the 3 different ways. What's the difference between expressions, vex, and VOPs? And VOPs is basically a nodal interface for vex. So in the point operator, which is really old school, and in position, as I said, there's at p.x. I'm going to put in here just because it's just so let's play around with the p.y. So we want to randomize p.y plus. We have a nice noise function in here, and the problem with noise is it's going to take 3 vectors for this noise to work. $sign, let's $sign. Oh, I gotta. Jeez. Let's put at p.x, at p.y, at p.z. So we can actually add some noise in the 3 components that way. And so then you can, so this is expressions. This is old as the hills. We've been doing things this way for many times. The problem that we have with this way of working is if we want to replicate this noise on all 3 areas, we actually have to put that into all 3 functions. And so by pasting it into all 3 functions, we now get a noisy sphere. So it's a lot of work just to get a noisy sphere. With attribute wrangle, we now have it's a much more efficient, by the way, in that it's threaded on the CPUs. So vex by default is threaded on the CPUs. So if you can take advantage of vex, do so. So the difference here is we're going to do similar things. So at p plus equals, and we're going to add some noise as well. But in this case, we used position for the noise on the point stop. We just put at p single, and it does all 3 components at the same time. Now the third one is the attribute VOP. Whenever I'm dealing with patterns, I invariably go to the attribute VOP. So that's the difference between that. So one uses expressions. Yeah, they're handy, but when it comes to doing the more elaborate type noises and expression functions, it's far easier to do a wrangle on those attributes. And the third way is if I'm really working with patterns, I'll go inside of the shader network type workflow, which we haven't looked at yet. That a lot of you I know are desperate to have a lot more information on VOPs. I always go to the noise, and here I always start off for some reason just go standard to the regular where is it? It's regular cellular, not cellular, but I always go for the just regular turbulent noise. And green means vector. P is at P, wire that into the position, and then we can wire that. And turbulent noise, we can output 1D or 3D. In this case, if we want to add it to P, we put on an add operator. And it's the same thing, same function, same logic, but just doing it in a graphical way. And the nice thing about VOPs is it protects us from typos. You can put that out to P. And then there's your position. So we're using all 3 different ways to wipe out. The nice thing about this is it makes it really easy to promote, oh, just didn't mean to do that, Control Z. Middle mouse on any one of these guys to promote the parameters to build a really nice artistic friendly interface. And there you go. So 3 different ways. Hardly anybody does it this way anymore. You'll still see some legacy files that do that. Most trivial little things that we do to attributes, creating attributes, just adding a little bit of noise or creating a little bit of variation is done with the wrangle. But if you're getting into any meaty, really complicated or challenging or very expressive workflows or attribute management, you can do the attribute VOP, and because there's a whole slew of really nice patterns geared up, plus it saves you from typos. So hopefully that answers that question. More questions?
Yes.
Let's keep on going. Unless you guys want to go, it's 5 minutes over. So another one. Oh, what's the best way to map the values of a noise to a range from 0 to 1? Yeah, you always get a different range. The answer to that is use the unified noise. So if I go inside the attribute VOP, there is a node called unified noise, and unified noise does all of that for us. So if we go, let's actually do the same logic we use in SOPs, you can use in VOPs. Let's put on a switch operator. I'm getting used to this keyboard. The delete key is really tiny. I'm sorry, my fault. So tab, switch. Good. Put that down so we can actually put that into there. And then we can put this. And we just want to do the noise. Unified noise has the same thing. It can output 3D noise as well. So 3D in, 3D out. And we can use the same position if we wanted to. There we go. And then I can wire the switch into the result of the add. And then we can switch. Unified noise will unify between 0 and 1, or -1 and 1, depending on the noise that it is that you're using. So it's all kinds of options inside of unified noise, for instance, Perlin noise and so on and so forth. So if I go up again here and switch, I should switch it to 2, and I can dive inside of that. Another nice feature of VOPs that we added in Houdini 15 is I can get a visualizer for anything in here just by tapping, select the node and hit the X key. X is in Excalibur, I guess. X. And that'll add a visualizer for me. And of course, a sphere with such a low resolution is going to look sucky, so let's add a frequency of 20, get some nice polygons going in there. And then we can go back into the attribute VOP. And now we can pre-visualize our noise on our geometry as well. And by the way, you can use X on whatever you want, so if you hit the X key on this guy, it'll update to that as well. And then you can start visualizing the color on there. I love these visualizers that we added a release ago. And you can increase or decrease the frequency. Now these will be normalized either between 0, 1, or 1 and 1. So it's up to you. And unified noise is the way to go. If you want to have normalized noise, do that. So next one.
There was a question about the difference, if there's any difference in speed between VEX and VOPs.
Once the code is compiled, no difference whatsoever, really. They're all calling the same functions. We use this open source application or plugin dependency called LLVM, and what it does is it uses fuzzy logic, and it's mainly meant for optimizing compiling of operators and compilation of code. And we use that to basically turn these VOPs into machine code as efficiently as you would get with VEX. The only downside is don't you ever keyframe animate inside of here. If you keyframe animate, let's say for instance on the unified noise, even though I could, if I wanted to write $FF in here, for instance, I could do that and it would work. The problem is, this is like telling Houdini to recompile this network every frame, and that would be wholly inefficient. So that's something you don't want to do. So never keyframe inside of here. Add a parameter, for instance, if it was at the final amplitude. So final amplitude's up here. If it's somewhere here. Final scale, I can promote that parameter. And then I get that parameter up top. And then I can keyframe that if I want to. So, and that's the way to do it. So at the end of the day, it's really no difference in performance.
What is fuzzy logic?
What is fuzzy logic?
Should ask Neil that on the forums.
You can ask that on the forums, and perhaps Neil would. Basically, it's in my layman's speak, I guess fuzzy logic is just it's an approach or a way of mocking the way that the brain works. Very, 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 very trivial way of doing that. but it adds, it's different depending on what you want to do too. But
Didn't Al Gore invent fuzzy logic?
Al Gore did invent. I'm not gonna. Oh boy. So what questions?
How important is knowing Python?
For a Houdini user, not at all. To be blatantly honest, if you're doing visual effects work, and I was a supervisor, and I saw you playing with Python for 2 days on something to automate something that you just had to deliver shots on, I'd be concerned. So Python is something that you can use to customize Houdini once you're in that role. If you love building tools, if you love creating infrastructure to create tools for others to use, absolutely. And that in itself is its own discipline, because I find that a lot of Houdini users will overcomplicate really simple things. And you really need to stop that. Just get to the meat of what the problems are. So as a Houdini user, Python is a luxury. It's not mandatory at all. And I guess we'll wrap it up. God, lots of questions. I'll get to these questions as well.
So we'll bundle these questions up,
Yeah.
put them with the downloadable files. The video will be sent out to everyone that registered this week.
Yeah.
And next week we'll post it publicly on Vimeo.
Fantastic. Yes. Thank you, guys. Again, these are just foundational framework things, us feeling the waters, and then we'll see specifically what the needs are, and we'll use the interactive medium where it makes best, and then we'll do formal recordings where they make best as well. So I really like this interaction that we have, though. It's pretty cool, and you end up doing stuff that you didn't think you would do. And as you realize, ask a question, right? And let's see what we can come up with. Okay, thank you very much, guys. Until next time. And I guess, Chris, you'll have that out next time, right? The list of, we have a whole bunch of webinars lined up for us.
We're going to publish the schedule on our website, and you'll get to see what topics are coming and all the dates.
Yeah, we're going to have some guests too, so I'll have some other people helping us run these things that are more specific to the various tools we're talking to. Okay, thank you very much, guys. Till next time.